Hello class, welcome to our physics lesson. Today, we will learn about series and parallel connection. Have you ever noticed Christmas lights where one busted bulb caused all the lights to turn off? But at home, one appliance stops working, the others still continue operating? This happens because electrical circuits are connected differently. Some use series connections while others use parallel connections. Today, we will discover the difference between these two circuit types. At the end of this lesson, you should be able to identify series and parallel connections, explain how electricity flows in each type of circuit, and compare their characteristics and uses in real-life situations. Electrical circuits are very important because they power many things we use every day, such as lights, gadgets, appliances, and even school equipment. Understanding circuits helps us know why some devices stop working completely when one part fails while others continue functioning normally. A series connection is a circuit where components are connected in one single path. This means electricity has only one route to follow. The current that passes through the first component is the same current that passes through the others. To represent this relationship, we use the formula current is equals to current sub 1 equals to current sub 2 equals to current sub 3. This formula means the current is equal throughout the entire series circuit. An example of a series connection is a set of Christmas lights connected one after another. Electricity flows through each bulb in sequence. Because the components depend on one another, if one bulb is removed or damaged, the entire circuit stops working because the path of electricity is broken. Series circuits have several important characteristics. First, they only have one path for current flow. Second, the current remains constant throughout the circuit. Third, the components are connected in a straight line. Lastly, if one component fails, the whole circuit stops functioning. Advantages of series circuits is that they are simple and easy to build. They also use fewer wires, making them less expensive. However, series circuits also have disadvantages. If one component fails, the entire circuit stops working. Also, bulbs became dimmer as more components are added. A parallel connection is a circuit where components are connected through separate branches. This creates multiple paths for electricity to flow. Unlike series circuits, each component can operate independently. The formula for total current in a parallel circuit is current total is equals to current sub 1 plus current sub 2 plus current sub 3. This means the total current is equals to the sum of the currents in each branch. A good example of a parallel circuit is the electrical wiring in our homes. Appliances like televisions, lights, and refrigerators are connected in separate branches. This is why when one appliance stops working, the others continue functioning normally because electricity still has other paths to flow through. Parallel circuits have multiple paths to current flow. Each component works independently from the others. All branches receive the same voltage from the power source. Also, if one component fails, the rest of the circuit continues to operate. Advantage of parallel circuits is that appliances work independently, making the system more reliable. Bulbs also shine brighter because each branch receives full voltage. However, parallel circuits require more wires, making them more expensive and slightly more complicated to install. To compare the two circuits, series circuits have only one path and all components depend on each other. Meanwhile, parallel circuits have multiple paths, allowing components to work independently. Series circuits are simpler and cheaper, while parallel circuits are more reliable but more complex. In summary, a series circuit has a single path for electricity, causing all components to depend on one another. On the other hand, a parallel circuit has multiple paths, allowing devices to continue working even if one component fails. Both types of circuits are useful depending on their purpose and application. Now, let us test your understanding. I have 3 questions. Number 1. Which type of circuit has one only path for current? The answer? Series connection. Number 2. Which connection allows appliances to work independently? The answer? Parallel connection. And last question. What happens in a series circuit when a one bulb is damaged? The answer? The entire circuit stops working.